This video is a hands-on introduction to S3. First, we will talk about S3 from an introduction perspective. Then, we will do hands-on with S3, where you will learn how to create an S3 bucket, how to upload an object, how to view the uploaded object, and some other related concepts. Amazon S3, which is Amazon's simple storage service, is one of the main building blocks of AWS. It's a widely popular AWS service. Many websites use Amazon S3 as a storage backbone. Many AWS services use Amazon S3 as an integration layer as well. S3 is a cloud storage service of AWS, built to store and retrieve any amount of data from anywhere. It provides a rich set of APIs to store and retrieve data in the cloud. Let's look into its essential features. The first noticeable point about S3 is that it is an object storage service. It can be used to retrieve any amount of data from anywhere. It is highly durable. S3 storage is designed for 11 nines of durability over a given year, across multiple availability zones. That means if you have 100 billion objects, you risk losing only one of them per year. It stores data across different storage classes to reduce costs. It protects your data with unmatched security, compliance, and audit capabilities. For example, it maintains various compliance programs such as PCI DSS, HIPAA, FISMA, and many others to help you meet regulatory requirements. It is highly available. Data is replicated in multiple AZs to provide high availability. It is highly scalable and can easily manage data at any scale. Let's understand the phrase object storage, because this is the key to understanding S3. We are more familiar with file storage, which is a type of storage system used by operating systems. However, S3 is not a file storage service. It is an object storage service. This is a crucial concept to keep in mind. The question then is, what is object storage? In object storage, objects are the distinct units used to manage and manipulate data storage. In object storage, there is no folder or hierarchy concept as we have in file storage systems. Instead, in object storage systems, everything is stored in a flat address space, also known as a storage pool. In AWS, this storage pool has a particular name, bucket. Another essential point about object storage is metadata. Metadata about objects is attached to stored objects, which is one of the reasons that we can do high-performance analytics on AWS. That's why, even without knowing the contents of the objects, we can still query them, because metadata is attached to each object. Another feature of object storage systems is that they can be scaled out. This is the key reason the S3 storage system has virtually unlimited scalability. The question is, what is the term scale out in a storage system? To answer this question, let's understand the types of storage systems. There are two types of storage systems. Most of us are familiar with classic scale-up storage, as it is used in file-based storage systems. The other one is scale-out, which is closely related to object storage systems. Let's look into classic scale-up storage. In a scale-up system, the storage scalability is limited by how many maximum disks can be attached to storage controllers. You cannot add more storage if a machine has reached the limit of how many maximum disks can be attached. On the other hand, with scale-out systems, you have a cluster of machines forming a storage address space called a storage pool, or bucket in AWS terms. To increase storage capacity, you add more machines, which makes scale-out systems virtually unlimited in scalability. Object storage characteristics, such as storing objects in a flat address space, metadata, and scale-out, are the critical factors driving S3 features. We talked about S3 object storage characteristics, such as storing objects in a flat address space, metadata, and scale-out, that lead us to use the terms bucket and objects. Let's talk further about S3 buckets and objects, starting with the S3 bucket. Amazon S3 allows users to store objects in buckets. Buckets must have a globally unique name. Buckets are defined at the region level. Regarding the naming convention for buckets, a bucket name must start with a lowercase letter or a number, and must be between 3 to 63 characters long. No uppercase and underscore characters are allowed. A bucket name cannot be an IP address. Let's talk about S3 objects. Each S3 object has a key. The key is the full path of the object and comprises the prefix plus the object name. One important point to remember about S3 objects is that there is no concept of directories within buckets. Though the S3 UI may give you the impression otherwise, it's just an S3 object key with long names containing slashes. The S3 object's value is the content or body. The maximum object size is 5 terabytes. If you upload an object of more than 5 gigabytes, you must use multi-part upload. In general, when your object size is around 100 megabytes or more, you should consider using multi-part uploads instead of uploading the object in a single operation. Using multi-part upload improves throughput. You can upload parts in parallel to improve speed. The S3 object also contains metadata, a list of text key-value pairs. The metadata can be system or user metadata. The S3 object can also have Unicode key-value pair tags, up to 10. The S3 object also contains a version ID if versioning is enabled. Let's talk now about object versioning on S3. You can version your objects on S3. It can be enabled at the bucket level. It's a best practice to version your buckets. Versioning protects against unintended deletes. It provides the ability to restore a version and roll back to a previous version easily. An important point to remember is that any file not versioned before enabling versioning will have null as its version. Suspending versioning does not delete previous versions. Let's talk about how S3 works. First, you create a bucket in S3. Once you have created the bucket, you can move your data, such as analytics data, log files, application data, images and videos, and backup and archival data, to S3 from wherever it lives. In the cloud, in applications, or in an on-prem environment. You can control access to data. You can leverage storage classes to optimize cost. You can replicate data to any other AWS region. Remember, your bucket is region-scoped. For example, you create your bucket in the Northern Virginia AWS region. If you would like to access your bucket in the Mumbai AWS region, the bucket will not be visible there. What you can do is use the S3 replication feature to replicate the bucket from the Northern Virginia region to the Mumbai region. This also helps reduce latency for your users accessing your bucket from near the Mumbai AWS region. You can access the S3 bucket from on-prem. You can also protect and secure your data. Once data is in S3, you can use it for various purposes, such as AI, ML, and advanced analytics workloads, to gain insights into your data. Or you can use it for general-purpose storage and retrieval. Let's talk about S3 use cases. You can use S3 to build data lakes, a typical use case for many large organizations moving to the cloud to run big data analytics, AI, and ML workloads. Another use case of S3 is to back up and restore critical data to meet RTO, RPO, and compliance requirements by using S3 replication features. Another use case of S3 is for long-term data archival at the lowest cost. You can move data archives to Amazon S3 Glacier for lower costs. This helps eliminate operational complexities. Our final use case for S3 is to run cloud-native applications. You can build fast, powerful mobile and web-based cloud-native apps with S3 as a storage layer that scales automatically with high availability. Finally, let's look into S3 pricing. You pay for storing objects in your S3 buckets. You pay only for what you use. Your rate depends on your object size, how long you store the objects during the month, and the storage class. There are per-request ingest charges when using put, copy, or lifecycle rules to move data into any S3 storage class. There are 6 Amazon S3 cost components to consider: storage pricing, request and data retrieval pricing, data transfer and transfer acceleration pricing, data management and analytics pricing, replication pricing, price to process your data with S3 Object Lambda. Now let's do hands-on with S3. So, here I am in the Amazon S3 console, and the first thing I need to do is create a bucket, because this is where the data will be stored. I'll click on Create Bucket. A bucket must have a unique name, so I'll enter Test as the bucket name. Let me scroll down and click Create Bucket. If you notice, I get the message, bucket with the same name already exists. This means that someone else has already used this bucket name. Now, even though I have never created a bucket named Test in my S3 account, as you can see, there are no buckets listed in my account, the name is still unavailable because bucket names in S3 are unique across all AWS accounts globally, not just within your account. So, if I try to create a bucket named Test again, I'll still get the same message. Bucket with the same name already exists. Since the name is already taken by someone else, I cannot use it. The important point here is, when you create a bucket, the name must be globally unique. One common way to ensure uniqueness is to include your domain name as a prefix or suffix in the bucket name. Another point to note is that bucket names are global in scope, but the buckets themselves are created in a specific AWS region. You can see that the region selection options are available. I'll select US East, North Virginia, since it's nearest to my location. However, you should choose the AWS region that's closest to where your users or applications are located for lower latency. Although the name must be unique globally, the bucket and its contents reside only in the chosen region. Scrolling down, I see that object ownership is set to disable ACLs, which is fine. Public access is blocked by default, which is a good security practice. Bucket versioning is currently disabled, and the default encryption settings are fine for now. I'll click Create Bucket. And now I can see that the bucket has been successfully created. Here is my bucket in the list. If I click on it and go to the Properties tab, I can see that the bucket is in the US East North Virginia region. I can also see its ARN, Amazon resource name, and the creation date. Now, I'll go back to the Objects tab and upload a file. The destination is NordXS3 demo, meaning the file will go into this bucket. I'll click Add Files, select AWS logo.png, and click Upload. Once it's uploaded, I'll click Close and see it listed in the bucket. If I click on this file, I can see details such as its size, type, and object URL. I can also copy the S3 URL, download the file, or open it directly. If I click Open from here, the file displays correctly, because S3 generates a pre-signed URL that includes a signature verifying my identity and permissions. However, if I copy the public URL and open it in a new browser tab, I get an Access Denied error. That's because public access to this bucket is blocked. Without proper permissions, the object cannot be viewed via a standard public URL. Now, I'll go back to the bucket and create a folder named Images. Inside this folder, I'll upload another file. After uploading, I can view it the same way, either through a pre-signed URL or by attempting the public URL, which again will be blocked due to public access restrictions. As you can see, the S3 console works very similarly to other cloud storage services like Google Drive or Dropbox. You can create folders, upload files, and manage objects. I can also delete a folder entirely by selecting it, clicking Delete, typing Permanently Delete as confirmation, and clicking Delete Objects. The folder is now removed. That's it for this hands-on demonstration. In this lecture, we covered how to create an S3 bucket, How to ensure bucket name uniqueness. Choosing a region for your bucket. Uploading files and viewing them. Understanding pre-signed URLs versus public URLs. Creating and deleting folders in S3.